Hi everyone, welcome to Java programming again. This In this video we are going to get started with memory management in Java. So up to this point of time you have learned so many concepts associated with Java programming such as functions, various data types, arrays, and your linked list, queue, and other different types of constructs as well. So how we can this memory management, it basically deals with how we can effectively and efficiently use those concepts that we have learned already in Java programming in a much efficient, more organized way. So memory management can also be termed as or called as process of allocation and deallocation of objects, and Java always does the memory management automatically. And Java uses an automatic memory management system called the garbage collector. So before to get started with the concept, let me just enlighten with the concept of array list that we have covered already. So as you know, an array list stores a list of items in contiguous memory locations, which enables immediate access to any element at index of array list using various methods. If you remember, we have used get, set methods, and so I'm going to show you one example here. Using the array list, we are trying to see how different elements are getting allocated to the array list and what happens when a new element needs to be inserted at a particular location which will be specified. So I'm going to start this activity. Mm, Okay, so here in the left hand side, as you see, we have an instruction, and in the right hand side, this is your array list, how it looks like. So each element in the array list are organized in separate slots or boxes, and in the left hand side, these are the references or memory addresses allocated to each data item. And here in the right hand side, it gives us the idea about what is happening actually here. So whether you are in I mean, these are all the use of get functions, so all elements are getting inserted to by the use of these functions here. So in which location particularly you want to enter the value, um, that's all. So let me run it again to show you what is happening actually. I'm going to start it again. So here what it needs to insert one element, that is 29 to the position 2. So let's start. Mm, okay, so in order to enter the element at the location 2, okay, so where the address is 88 but the indexing will be done in this way, starting with 0. 14 is at 0 index, 1 index contains 22. Likewise, the initially the third element, that is our index 2, was containing 31, but here in this place, 31 place, we want to enter 29. So what it has to do, it has to take each element or move their position one position ahead in the array list in order to make space for 29. So first it need to empty this space, then only it can add it to the array list. So this is what is going on here in this activity. So what actually happens here, so while inserting an element in the locations other than the end of the array list, it requires making room by shifting higher indexed items, whatever I just showed you here in this activity. So similarly, removing an element also of an item requires shifting higher indexed items to fill the gap as well. So each shift of an item, the way in which you shifted it one position ahead in order to make the space of 29, So each shift of the item from one element to another element requires a few processor activities or instructions, and this is an issue or problem which exposes the array list add or remove performance problem. So what happens actually for array lists with various number of elements, a single call to add function or remove function, it can require 1,000 of instructions in order to execute, um, to successfully have the insert and remove operations to be carried out in a more effective way. Okay, so here shifting of all the elements done by the add or remove actually requires several processor instructions per element, and it may take significantly a long amount of time. So I'm going to show you one program. In this program, what is happening actually, we are trying to demonstrate the issue that was occurring in the activity I was showing you earlier. So here in this program, the user is trying to input an array list size and number of elements to insert, and then program carries out with several tasks along with several instructions, and um, through it we are going to expose or deal with the issue that is raging or getting raised. So let's just go through the program here. First, let me just tell you about the import statements. ArrayList and scanner for use of the ArrayList and the other scanner input output functions. Um, so this is the class name, then a CNR object created, then one ArrayList created myints, which belongs to the generic class integer, then num element. Here we are keeping track of the num element, which deals with the size of the array list, and yeah, num ops is used to perform the appending or the adding operations, inserts operations, as well as the remove functions. So, and I is used for another index variable. So first we are trying to enter an initial array list size. So that size will be now taken care with this next end function. So here it will ask you to enter one array list size, then how many number of array list adds do you want to perform, that you need to enter num ops through num ops variable. Then we are going initially, whatever it maybe have some garbage values or unmeaningful values, so in order to clear them we are calling the clear function to make the array list initially empty. Then we are trying to add 0 to all the list size, I mean throughout the list num element we are trying to add at first 0 into all the locations. Now next what we are trying to do, for each location in the array list we are trying to set all the values, which values again starting with the index 0 up to the size of the array list with 777, this element. So now 0 will be overwritten with 777. Now next is what we are trying to add 888 to the elements. Now the next function it's trying to add, at the 0 location it wants to add 444. So in order to do that it need to shift the array list um, element wise in the list, so that it when one space will be made for the first element with the index 0, and it will try to enter 444 there. Mm, yeah, and then trying to remove the element. So let's see what is happening here. Let me run the code. Suppose array list size I will enter 0 0 0 0 0, suppose 100,000. Then next I want to add 40,000 suppose. So total number of array list adds will be 40,000 and the initial array list size is 100,000. So see, if you observe the first adding elements to the array list, okay, adding elements to the array list, that means this portion and yeah, and this portion also, it all happened in the real time with proper timing that we have in our hand. But here the rest of the statements that we have, okay, it took some time to get on here. I can show you again with having a little bit longer in size, maybe 1 million, 100,000, yeah, okay, and then 40,000 as the add. So see, after 40,000 additions at the index, okay, so see how it's not terminating and how it took some time to give us two outputs for the remove, yeah, this part to remove the element and to add the element, because the appends or the additions are fast because they do not involve any shifting of items, whereas the insert requires a number of elements to be shifted one at a time. So in order to add one element at a specific location 0 here, it need to shift all the elements. So for that period of time for shifting, it has to wait. And also remove, also it does the same thing. After removing everything, it has to move back again all the elements one position in the upper part. So one way to make inserts and remove faster, we may use a different approach of sorting a list of items, okay, in order to remove this type of issue or problem here. We can adopt a different way or different approach, and this approach does not use contiguous locations. Instead, each item will contain a pointer to the next item's location in the memory as well as the data being stored. So I'm going to take you to the uh, page again here. Yeah, here, see, this is our example that I want to show you how to solve the issue that we have in here. Okay, so here we have let me just take you through the activity. We have two nodes A and C. So here what happens, um, so this approach does not use the contiguous or continuous memory location. So instead, each item, that is A and C, individually will contain a pointer to the next item's memory location. So A will have a part in it so that it will contain a pointer to the next node, that is C, as well as the data being stored. So thus inserting a new element, suppose say you want to insert a new element B into it, if we can update the reference part of A which was keeping the reference of C, pointer of C, and in that place we can update the reference of B here so that A will be connected with B, and then B, if B's reference part will contain the pointer to, or will contain the reference to the C node, then B will be entered in between A and C. So let's first let me take you through the process here. First, in the list we have A and C. After that we may have some other nodes as well, but it's not shown here. So in the list, first A node has data A, and then in the next part of it, so this A and 88 data, and the next part, it is termed, or it can be considered as the first item in the list, that is A. So A's next part, the first item's next part, is containing the address of the next node's reference, that is 88, and then C is containing C is a part of the second item, and C is following part, or the next part is containing the address of next element's reference, that is 113, which is not given here, not shown here in this picture. Here now, if we try to insert a new item after A, then new item B is first, it first will be stored in the linked list at a certain memory location. Here it is 90, and now B is next part, the third item's next part, reference must be overwritten with, or must be stored with the address of the A's next. Okay, so what happens now? Now A is updating to point to the location B 90, because A's next part is now replaced with B's data part reference 90. So A is now next pointing to B, and 88 is now the address of the C. So this is how B will be now moved after A, and then C will be following after that. So this is your basic linked list concept, and this is how, I mean, what we had initially, what were the problems, and to overcome those problems, what are we supposed to do, and what is the structure, basic structure of this new approach that is called as linked list.